Hey, what's going on? This is Tino, aka The Dirty Quant, and welcome to my channel. Today I'd like to compare pre-populating arrays versus building them on the fly and show you how to speed them up by over 60 times. If this is the first time on the channel, welcome. I usually cover maths, Python, statistics, finance, all good things like that. Remember to like, subscribe, you know the deal. All right, let's just jump into a Jupyter notebook and have a little bit of fun. So it's essentially try and compare what is faster. Building these arrays on the fly. So we've got an array, a numpy array, whatever it is, right? And should I just keep extending it, so appending to it on the fly, or should I be pre-populating essentially with maybe zeros and then adding data as I need it? So obviously this might not be an exactly fair comparison because you might not know how much data you need, right? So you might say, well, new data comes in, it might be length 20, it might be length 100. I don't actually know that, but let's say most of the time you might do that, right? It's a process, it's a finite process, finite number of days, finite number of samples. So you do know how long it is, right? What you don't know obviously is what data you're going to populate in it, but that's what we're going to try and compare here. So here I've got a little function that builds something on the fly. So the way it works, you populate a numpy array with just a 0, right? And then what I'm going to do is just cycle through a sample size of maybe 1,000. I've just done -1 because I already have my initial one, right? And all I'm going to do is append. So I'm going to take the original array and just append to it a number, right? And then just save that to A and loop through that again and again, right? So that's just going to extend my array. As I get a new piece of data, I'm just going to make it longer. So it starts as size 1, and then it's going to get to size 2, 3, 4, 5, and so on and so forth, right? I'm just going to run that, and I'm just going to time it. So how long does that take to run with an array size of 1,000? So 5.1 milliseconds, which is, pretty quick. It's definitely no slouch, right? So let's see how that scales up. So I've seen my other videos, I do something similar. I see, okay, well, is there a bottleneck if I have a very small sample size, or I increase it, does it take longer and longer? So I'm just going to run that and wait. All right, so little chart here just to see how does on the fly populating the array scale up. So I've just started with an array size of 10 all the way to 100,000, and it's pretty much linear, right? So it doesn't take any more time. Well, it doesn't take any sort of additional time if you have a smaller one compared to a longer one. It scales linearly, right? Pretty straightforward. So what's the alternative to this? The alternative is to pre-populate it. By pre-populating, it says, I mean, getting an array and making it already the size that you know is going to be at the end, but you're not going to populate it with data yet. You're just going to populate it with dummy data, whether that be zeros, ones, whatever you might want to populate it with. And as your process creates that data, we just insert it in the right position, right? So pretty straightforward. I'm going to use the numpy.zeros. The way it works, you just say, hey, this is the sample size I want it to be, and dtype int 32. I had to specify the dtype because this numpy array is also type 32. So I wanted to have it a like-for-like comparison. It doesn't actually default to dtype in 32. It actually defaults to something else. I think it was float 64, whatever it was, right? I just wanted to make it like-for-like. Pretty straightforward. So I already have B. B is already the size that it needs to be, whether it be 1,000, 100,000, etc., right? So I'm just going to set the first one to 0. So it's pretty comparable to the above. And then we're just going to extend it to be the size that it needs to be, right? So we're just adding one value and telling it, hey, put it at this position I, so position 1, 2, 3, 4, 5. So just essentially replacing those zeros that are already pre-populated with data that I wanted to. Great. So what I like to do is just to show you the type of variable. So there's a nice little command called whos. So you just run that and it shows you the variable. the type that is, and any information that you need. So essentially teltells you, okay, this is both A and B, numpy arrays, and they're 1,000, and type int32, and they take up 4,000 bytes, right? Pretty handy, bit geeky, but just to show you that they are the same type of data, right? Might do another video just so you see, does the type of data that go in matter? Does that sort of slow the extension of the numpy array? Anyway, cool. Let's see what pre-populated function, how long that takes to run, right? We wait. All right, so 98 microseconds. So, you know, extremely fast. This one was 5.81 milliseconds, which is 5,801 microseconds. So really quite a lot quicker. Again, let's see, does it scale up linearly if we extend that sample size from 10 all the way to 100,000? Does it scale linearly? Beautiful. So perfectly straight line. So yes, pre-populated scales pretty linearly. Not that I wasn't expecting anything different. And last little piece of the puzzle, time taken. So this is essentially the time that it takes. I'm just going to put it in terms of a ratio, a bit easier to understand. So pre-populated takes obviously 1 times itself, on the fly essentially 59, so 60 times slower to do the same task. And I learned this when I was doing, you know, in my MATLAB days, when you had to sort of be very efficient. So some of the computers, you know, you had, yes, a lot of RAM, but you also needed a lot of RAM, right? So you just had to use everything to its max potential, trying to be as efficient as possible. And, you know, when you do loops thousands and millions of times, and you can shave just a little millisecond here, millisecond there, you can speed up your workflow massively. I'm not saying this is going to speed up your workflow 60 times. You're still dependent on the original data generating process. This was literally assigning a number to the array, but it's a piece of the puzzle where you go, you know what, I can save time here. I'm doing loops again and again and again. I can save a good chunk of time. I'm making it efficient, streamlining it. Let's say this was your array of size 1. So you've just got a little choo-choo train, and your computer is going to find a little slot for it. Okay, so we got size 1 and it finds a slot. Fantastic. You're just going to sit there. But what if you come along and say, hey, I want to append my array and make it 1 bigger? So you go, well, it's not going to fit there. I need to move it. I need to move it to there. So now your array is size 2, and then you're going to pop a little piece of data on it. Great. Next, you say, okay, well, I want to make the array size 3. So you need to find an even bigger spot. You probably want to move it up there, extend the array. So what's the alternative? The alternative is to pre-populate it. So we pre-populate it and then add the data at our own leisure, and you're done. And that is quicker. Anyway, hope you enjoyed the video, and I'll catch you on the next one. Cheers. Bye.